Alright, now that you know the basics about logarithms, we have a few other specifics that we need to talk about. First off, there's two kinds of logarithms that are going to show up, especially on your calculator. See, when you had log base 3 or log base 8, you couldn't use a calculator to do that because on your calculator, there's only two bases that it'll work with. We have first off the common logarithm, and that's where you have a base 10. So base 10 is the most used one on your calculator. It's partly because, you know, our number system is base 10. And what happens is, you'll see here that I also wrote log of x without a base on it at all. And that's because if it's a base 10, you don't have to write the base, which also means that if you don't have a base here, it's automatically going to be a 10. Now you'll see on your calculators there is a log button, and that if it just says log, that means it's log base 10. The other kind of logarithm that we can have is called a natural logarithm, and that is base e. If you remember back, that number 2.71 ... It kept on going forever and ever. It's like pi, it goes on. If you have log base e, that is called a natural logarithm. And in fact, we rewrite it. Instead of saying log anymore, we say ln of x. And so ln of x means automatically it's log base e. We'll never see log base e. We'll never see it written this way. You will always see it written natural log of x. So if you ever wonder what is the base of natural log, you can automatically know the base is e for natural log. So we'll talk about this more in class, but you can use a calculator to find these things: log of 5, natural log of 0.1, log of 7, natural log of 0.25. We'll do that in class in the calculators. Okay, in class I have a video to show you on this, but what we're going to talk about is something I call Tetris effect. Now, Tetris effect is actually a made-up term that I made up one time because what we're doing reminds me of the game of Tetris. So before I get to that, let me just go over what's going on here. So you'll see here I have log base b of b to the x. So what I want to point out that's really special here is that the base of logarithm is b and the base of the exponent is b. They're the exact same number. So because they're the exact same number, something really awesome happens. So to show you what happens, I'm going to say that this equals smiley face. Okay? So now I'm going to rewrite this into exponential form. And so in exponential form, I'm going to take my base, and remember logarithms equal your exponent, so my exponent is going to be smiley face, equals, and then remember what's inside the logarithm is what this is going to equal, b to the x. So notice, again, my bases are the same. That means x has to equal smiley face, or smiley face has to equal x. So that means smiley face equals x. So when you have log base b of b to the x, it equals x. Now where does x come from? X is the exponent. So what's happening is if your base of your logarithm and the base of your exponent are the same, your answer is the exponent. Now, that's actually pretty cool. So remember I talked about Tetris a little bit. So in Tetris, let's just remember what Tetris is. It's this game where these blocks come down, right? And you put the blocks together and they go like this, and then all of a sudden you get a block that can fill this in. And so what happens is this whole line here is filled in, and then magically, like this blinks and some noise happens like and this disappears completely. That disappears completely, and these blocks that are right here drop down. They drop down to the bottom of the screen, and now those blocks are now at the bottom of the screen. That's happening here. My base and my base match up. Okay, these are that row. The base and the base match up. So this is blinking and it's going, and the only thing that's left is this block up here, the exponent, and that drops down and becomes your answer. Now what I just said, all that Tetris stuff and the that I was just saying, that's all made up. That's just a way to remember it. It is not why it works, it's just a way to remember it. The reason why it works is over here, because when you put it in exponential form, you'll see that it has to equal what the exponent was. But that's one version of Tetris effect. The other one is down here. Now, if you have the base of your exponent is b, but here's what's weird. The logarithm is your exponent. Okay? So now the log is in the exponent. The base of your exponent is b, and the base of the logarithm is b. The same thing is going to happen. Okay, so let me erase that for a second. And let's just say that that equals smiley face now. Okay, this equals smiley face. And I'm going to rewrite it now into logarithmic form because right now it's an exponential form. So if I'm going to write in logarithmic form, I'm going to write log base, well, the base of my exponent's b, of what it equals, the smiley face. Whoops, that's not a smiley face. Of the smiley face equals the exponent, and our exponent is log base b of x. And so if I look at this, the base of the logarithm is b, the base of this logarithm is b. The only thing that's different is inside the logarithm. That means this must equal smiley face. Therefore, smiley face must equal x. So what's going on here is I've got all this stuff blocking up again, and the base of the exponent's the same, the base of the logarithm is the same. This is all blinking, going, and all that's left is going to be what's inside the logarithm, and that is x. And that drops down, and that's my answer. Again, just how you can remember it, not why it works. So let's look at an example, a couple examples actually. So here I have 10 to the log. Remember, if there is no base, that's a 10. So I've got 10 to the log base 10 of x. Now let me just go again why this works. So let's say that equals smiley face. So if I rewrite this in log form, it's log base of the exponent is 10, so the base of my logarithm is 10 of smiley face equals the exponent log base 10 of x. So smiley face must equal x. This must equal x. Okay? But of course I can go back and I can say, you know what? Base of my exponent is 10, the base of my logarithm is 10. All of that matches up. X drops down, my answer is x. So let's do another one. Here, the base of my log is 5 and the base of my exponent is 125. You're almost thinking, you know what? This won't work because they're not the same number. However, the tricky part here is that I'm going to rewrite 25 as 5 to the third power. Right? 5 to the third power is 125. And then, remember what if you have an exponent and another exponent, you multiply them. So it's log base 5 of 5 to the 3x. So the base of my logarithm and the base of my exponent are the same. And so those go, and my answer is 3x. My answer is just the exponent. Okay, let's look at this one. This is 10, and then log base 10 of 2. And so again, these are the same. The base of my exponent, the base of my logarithm are the same. So my answer is just what's inside the logarithm 2. Okay, for this one, again, the 3 and the 9 don't match up. So now I'm wondering what can I do? And so let me rewrite the 9 as 3 squared. And then the x is still there. And so we've got we've got Tetris effect here, and we get 2x. One more, you'll notice that I don't have a base on my log. Remember, if there is no base, it's a 10. And then 10,000 is kind of a big number here. Let's rewrite that as 10 to the 4th power, and there's still the x there. And so now the base of my log and the base exponent match up. I've got Tetris effect, and we've got 4x. Alright, now we're just going to talk about inverses real quick. Remember what an inverse is. If you had y equals 2x plus 1, the inverse, you'd switch x and y, and then solve for y. So subtract 1, x minus 1 equals 2y, divide by 2. So y equals x minus 1 over 2. So with logarithms, if I want to find the inverse, I have to switch x and y. So for this one here, I'm going to switch x and y. And now I have to solve for y. But if you remember my Tootsie Pop problem, I was telling you before this is inside a logarithm. I can't divide by log to get rid of it. Okay, it's inside of it. The only way I can get y out of it is by taking it out of logarithmic form and putting it back into exponential form. So exponential form says my base, my log is 3, so the base of the exponent is 3. Remember, your logarithm always equals your exponent, and then this will equal what's inside the exponent y. So the inverse of y equals log base 3 of x is 3 to the x equals y. That is the inverse. So then if I want to know the inverse of this next one, switch x and y. And then once again, I have to rewrite this in exponential form in order to get y out of there. And remember, the base of natural log is e. So this will be e to the x, I'm looking at the x there, equals what's inside the logarithm, y plus 1. And then to solve for y, I need to subtract 1. So e to the x minus 1 equals y.